BCPS mathematicians. Are you ready to exercise your math brain today? My name is Mrs. Potter, and I'm your host for this week's episode of Algebra 1 BCPS-TV style. Let's get ready to do some math with a positive growth mindset. Let's begin today by learning about some important math messages from Dr. Joe Bowler, a professor at Stanford University. Last week, we heard how important it is to make sure you continue to exercise your brain. Today, we're going to learn about something called a mindset.
That brings us to our second idea. It's really important that you believe in yourself.
We now know that your beliefs about your own abilities actually change the ways your brain works when you do math.
Carol Dweck has shown that everyone has a mindset, a set of beliefs about their own learning and potential.
People with a growth mindset believe anyone can learn and that they can grow their brains through hard work.
People with a fixed mindset think that a person is either smart or not, and that smartness is unchangeable.
Oh, a D-. I am not a math person. I just can't do this.
Oh, a D-. But that's okay. I'll learn from our mistakes and try harder next time.
These graphs show students' maths achievement in 7th and 8th grade. The students with a fixed mindset, you can see, stay at the same level, but the students with a growth mindset are always doing better and better.
This is because people who believe they can do something work in better ways. They are more persistent, they keep going when problems are hard, they don't stop when they make mistakes, they just keep going.
It is really important that you know that you can achieve anything and that you believe in yourself.
Last week, we learned that all people are math people and everyone can learn math to high levels. This week, we learned the difference between a growth mindset and a fixed mindset. When you have a growth mindset about learning mathematics, you keep going even when the work is hard, and you persist. That's one of the characteristics of good mathematicians. So let's have a growth mindset today about learning mathematics. Let's get ready to go. Let's get started with a think about it task. In this think about it task, we're shown 3 patterns, patterns A, B, and C. Stages 1 through 3 are shown for each of the patterns, and you're asked to draw stage 4 and describe how the pattern is changing. Victoria, Lily, and Spencer are going to work through each of the patterns. First up, we have Victoria. Victoria drew stage 4 and said that at each stage, another row of blocks are added horizontally and vertically. I wonder what she means. I think she might mean that inside this, the middle part of this figure is where the row and the column is being added horizontally and vertically. When I compare there, I see that. Lily took a look at pattern B, and again, she drew stage 4 for us. She said that at every state, a row is added on the bottom and left. So here's another row added on the left, and here's another row added along the bottom. And finally, we have Spencer, who said he drew us stage 4, but he also drew a little diagram here. So let's kind of see what he said. He said at every stage, a new column is added with the new height being x, which is the last height, plus 3. So let's take a look. From stage 1 to stage 2, we added 3 rows. And from stage 2 to stage 3, we also added 3 rows. I think that the way that Victoria, Lily, and Spencer thought about how the pattern was changing was excellent. But I want to show you another way to think about how the pattern is changing. If I put squares in each of the representations, I wonder what you notice and what you wonder about how the patterns are changing. Take a few seconds to take a look and see if you can come up with any descriptive words on your own. Looking at how patterns change is a really important part of being a good mathematician. We'll be coming back to this Think About It task in the Try It section, so keep these ideas in mind as we move forward in our lesson today. The material covered in our first learning objective for this week's episode is, today we will take square roots in order to solve quadratic equations. You learned in last week's episode how to solve quadratic equations by using a process called factoring, and this week we're going to add another strategy to your tool belt called taking square roots. The material in this lesson is the same as the material in your print packet for the week of May 18th, and this is the same as lesson 1. In the previous two lessons, you learned how to use factoring as a method to solve a quadratic equation in one variable. In this lesson, you'll learn another strategy to solve a quadratic equation. As you continue to learn additional methods to solve quadratic equations, it's important to start thinking about when you will use each of the different methods. The structure of the equation is one thing that you might want to notice when deciding on a method. Several examples will be shown today. In this example, let's learn about how to solve quadratic equations by using square roots. In this next example, example number 2, I'm going to solve the equation 2 times the quantity x minus 3 squared is equal to 50. This problem looks a little bit different than the previous example because instead of just squaring x, I'm squaring the quantity x minus 3. But my process is generally the same because I'm trying to get x alone. So I'm going to start with 2 times x, the quantity x minus 3 squared is equal to 50, and I'm trying to get this x term by itself. So I'm going to divide both sides by 2. So what I'm left with is the quantity x minus 3 squared is equal to 25. Now, in order for me to get the x minus 3 alone, I need to undo the square. And to undo a square, I'm going to take the square root. So I'm going to take the square root of both sides, and I'm left with x minus 3 is equal to plus or minus 5. I'm going to write these two solutions separately. There are two solutions because it's either x minus 3 equals positive 5 or x minus 3 is equal to negative 5. So I'm separating that into two solutions. And now I'm going to solve both of those equations. So for the equation on the left, I'm going to add 3 to both sides. So x is equal to 8. And on the equation on the right, I'm also going to add 3 to both sides. But for this one, the solution is x is equal to negative 2. So these are my solutions, but so now I'm going to check both of those solutions in the original equation. So I have 2 times 8 minus 3 squared equals 50. I'm checking to see if that's sure. So to evaluate the left-hand side of this equation, I need to apply the order of operations. So I'm going to do what's in parentheses first. 8 minus 3 is equal to 5. Then I'm going to apply the exponent. So 5 squared is 25, and 2 times 25 is 50. So that solution works. So one of my solutions is x is equal to 8. 2 times negative 2 minus 3 squared equals 50. I'm trying to check to see if that's true. So again, I have to follow the order of operations. I'm going to evaluate what's inside the parentheses first. Negative 2 minus 3 is negative 5. Negative 5 squared is 25, and 2 times 25 is 50. So that solution also works. So my other solution is x is equal to negative 2. So what I'm going to do now is check my solutions with a graph. One of my equations will be y equals 2 times the quantity x minus 3 squared. That's going to be the green curve. And one equation is going to be y equals 50, and that's the purple line. So when I look at this graph, I can see that the x coordinates of the points of intersection are negative 2 and positive 8. On the screen is the triad activity for this week's lesson. You'll notice that the patterns shown in the triad activity are the same patterns that we looked at in the Think About It task. Your job is to decide which function defines which pattern. So you have 3 functions listed here, and you're going to match those up with the different patterns. You're going to think about which pattern might have a step with 432 tiles in it, which one has a step with 195 tiles in it, and which one has a step with 404 tiles in it. You might consider using a graph, a table, you might solve some equations here. There are lots of different strategies that you can use to answer Part B. And finally, in Part C, you're going to describe and justify the steps to solve the equation that's shown for x. ax squared plus c equals d. You have all the information that you need to successfully complete this triad activity. In our first learning objective for today, we learned how to take square roots in order to solve quadratic equations. So now you have 2 different strategies that you can use to solve quadratic equations. First, you can use the taking square roots method that we learned in our first lesson this week, Or you can use the factoring technique that we learned about in last week's lesson. Make sure you have a growth mindset as you try the triad activities for this week. You got this. Before we move into our second learning objective for today, let's think about it. In this think about it task, there are 4 expressions listed on the left-hand side of the screen. The algebra tile representation is in the middle column. Your job is to determine how many unit pieces, whether positive or negative, would need to fill in the space in order to do something called completing the square. And then after you have identified the number of pieces that need to fit in that spot to complete the square, you'll write your new expression with the C value included in both standard form and in factored form. So let's see what the Potter family has to say about this task. So first up, Finley was asked to find the value of C that creates a perfect square trinomial in the expression x squared minus 6x plus C. You can notice that when Finley first answered, he wrote that he would need 9 negative unit pieces. And as we talked about it further, he changed his answer to 9 positive unit pieces because he told me that a negative times a negative would give him a positive. So his C value here is positive 9. And that correlates to the expression x squared minus 6x plus 9, which is the same as the quantity x minus 3 squared in factored form. Next, Tim was asked to find the value of C that creates a perfect square in the expression x squared plus 8x plus C. He told me that 16 positive unit pieces were needed, and he drew some lines to help him figure out how many unit pieces that was. That gave him the expression x squared plus 8x plus 16, which in factored form is the quantity x plus 4 squared. I'm going to leave the last one for you to try. See if you notice any patterns or repeated reasoning that's happening over and over again. And in our next example, we'll make a connection between the algebra tiles and an algebraic process that we can use to find the C value. In our second learning objective for today, we're going to use a process called completing the square in order to solve quadratic equations. So now we're going to have 3 different strategies that we can use to solve quadratic equations: factoring, taking the square root method, and completing the square. This learning objective is the same as the lesson in your print packet for the week of May 18th, and this is lesson number 2. In this example, we're going to connect what we did in the Think About It task, where we were finding values of C that created a perfect square with our algebra tiles, to an algebraic process that we can use to find the value of C that completes the square. So the first thing that I'm going to do is I'm going to represent x squared minus 6x with algebra tiles. So here's an x squared, and then I have 6 negative x's, so 1, 2, 3, 4, 5, 6. And I want to take these tiles and begin placing them in a square. So I will line up these pieces along the bottom, these x pieces along the bottom, and I will line up these x pieces along the side. So we can already see that I did something with those 6 negative x pieces. I took the 6 negative x pieces and I divided them in half to help me begin to create my square. So I'm going to just note that down on my algebraic side, that I had negative 6x, and I'm not going to include the x, I'm just going to include the negative 6. And I divided that in half, and when I do that, I get negative 3. And you can see that I have 3 negative x's along the bottom and 3 negative x's along the side. So my next job is to actually complete the square, find out how many unit pieces I need to put in this space right here to make a perfect square. So I first need to kind of think about this. I have a negative times a negative, which is a positive, so that means that my unit pieces are going to be positive. So I need to fill that up, so I'm going to do that here. And I can see that I have 9 positive unit pieces. Now, one way for me to think about how I can get 9 without actually using algebra tiles is to think about those 3 negative x pieces that I have along the side and along the bottom, if I multiply -3 times -3, I get +9. So let's go back over to our algebraic representation over here. If I have -3 and I square that or multiply it by itself, I get +9. So you can begin to see how it's possible for me to just look at the algebraic representation to complete the square without looking at the algebra tiles. So what I'm going to do now is I'm going to rewrite my expression x squared minus 6x, and instead of writing c, I'm going to write a +9. But I also want to represent this as a perfect square trinomial in factored form so that I can see what that looks like, and I can also use that to solve an equation if I'm asked to do that. So what I'm going to do is I'm going to find the factors that make up this product. So remember, the factors are going to be what's along the side and what's along the top of my algebra tile representation. So along the side, I have x minus 3. That's one of my factors. And my other factor, which I'm going to represent along the top, is also x minus 3. And I can rewrite that as the quantity x minus 3 squared. So that is how to connect the algebra tile representation with an algebraic process for completing the square. In this example, we're going to solve the equation x squared minus 4x equals 21 by using a method called completing the square. So first I'm going to identify the expression that I would like to complete the square, and that is x squared minus 4x. And I'm trying to find the value of c that will complete the square. So to perform the process of completing the square, you can think about this in terms of algebra tiles. I need to identify how many x terms I have. So that's the b value. So I have -4 or 4 negative x squared pieces. I need to divide those in half. So that's -2 on each side of my square. And I'm going to square that result. So I have -2 squared equals 4. So my c value is 4. So let me show you a picture. I have an x squared term. I have 2 negative x terms along the top and 2 negative x squared terms on the bottom. And in order to complete my square, I need 4 positive unit pieces. So now I'm going to add the c value to both sides of my equation so that I can rewrite the left-hand side as a perfect square trinomial. So I added 4, which was my c value, to both sides of my equation, and I'm going to combine any like terms that I can. So I can only combine 21 and 4, which is 25. Next, I'm going to rewrite x squared minus 4x plus 4 as a perfect square trinomial. So if I go back up to my algebra tile representation, I can see that this is x minus 2, and this is x minus 2. So x minus 2 squared is equal to 25. And now I'm going to solve this using the same methods that we learned about in lesson number 1 for this week. So I'm going to take the square root of both sides because I'm trying to get the x minus 2 expression alone. And right now it's currently being squared. So I have x minus 2 squared equals 25. And I'm going to take the square root of both of those. So I'm left with x minus 2 is equal to plus or minus 5. Now I'm going to write each of those as 2 separate equations and solve those 2 equations. So I have x minus 2 is equal to positive 5, and x minus 2 is equal to negative 5. So I'm going to add 2 to both sides of the equation on the left, and I get x equals 7. That's one of my solutions. And I'm going to add 2 to both sides of the right-hand equation, and I have x equals -3. So my two solutions are x equals 7 and x equals -3. But what I want to do is I want to check this with a graph. So I'm going to graph the equation y equals x squared minus 4x. That represented the left-hand side of the equal sign in my original equation. And y equals 21, that was the right-hand side of my original equation. And when I look at the picture, I can see that the two solutions are -321 and 721. And the x-coordinates of those solutions, or I'm sorry, the x-coordinates of those points of intersection are the solutions to my equation. In the try it portion of our second lesson for this week, you're asked to do two different things. First, you're asked to find a value of c that creates a perfect square trinomial, and then you're asked to write the perfect square trinomial in factored form. Take a look at example 1 in your print packet for some help with that. And our second task in the triad activity is to solve the equations by completing the square. So you can take a look at examples 2 and 3 in your print packet. Also know that example 1 was done in this video, as was example 2. In summary, our second learning objective for this week's episode was to complete the square in order to solve quadratic equations. So at this point, you now have 3 strategies that you can use to solve quadratic equations. You can factor, you can use square roots, and you can complete the square. Remember, that growth mindset is really going to help you when you try those triad activities. You got it. Thanks for joining in for this week's episode of Algebra 1 BCPS-TV style. You learned some new strategies for solving quadratic equations. This week, I want to challenge you to try something. I want you to either work out some of the think about it tasks with someone at home, or I want you to show someone all of your work in the triad activities. Remember, every time you complete one of those math problems, you're exercising your brain, and you're working to show your growth mindset in the area of mathematics. See you later.